Hello everyone. Today I bring before you an interesting question on projectile motion. This question might end up puzzling you if you do not understand the relationship between projectile motion and trigonometry. But I'm going to make it easy and simple for you to comprehend. The question reads, a projectile is launched on level ground. At the peak of its trajectory, it is h meters high. It lands 10 meters away from where it was launched. Show that the angle of launch is given by the expression theta is equal to tan inverse multiplied by 2h over 5. And then B, if the maximum height of the projectile is 7.5 meters, at what angle was the projectile launched? This is a standard exam question and it looks scary, but we can go through it step by step for easier comprehension. Without further ado, let's get right into it. We were given the range. The range here is 10 meters. We were not given the launch angle, but we were asked to prove this. We were asked to prove this. How do we do it? Okay, we're first of all going to solve for part A. Then when we solve for part A, we can now go ahead and solve for the launch angle, right? We were given that for the part A, the maximum height is h. We're just given h, nothing else but h. But for part B, we were not given the maximum height, right? Okay, so don't use 7.5 for part A. Use h for part A. Then use 7.5 for part B. If you use 7.5 for part A, you can't arrive at this solution here. Okay, but if you use h for part A, you'll be able to arrive at this solution. Now, what do we do in this very case? We can collect our data and start solving. We're given our range to be 10 meters. The range is simply the maximum horizontal distance the projectile covers. For example, since it was launched from here, okay, this is the distance it covered and then it fell here. So from the point of projection to the plane of impact, which is here, it covered 10 meters. So when the question says how far means range, okay? And for us to be given our range, it means that we're going to use our range formula in this case. The range formula is very important. And then if we're given our height, which is h, we're also going to bring in the formula for the maximum height. Now, you have to be very careful here. The reason why I'm going to use the generic projectile motion formulas in this very problem is because it was launched on level ground and it also fell on level ground. Suppose it were launched, let's say that this were launched from a cliff, something like this, okay? We cannot use the generic projectile motion formulas. Why? Because it did not land where it was launched. For example, it's not going to land on the same plane, okay? So if it were to land somewhere here, then we can use the general projectile motion formulas. But since it's not going to land on the same plane, there is no point of using those formulas. It is baseless. You end up getting incorrect solutions. But if it's a case like this one here you have on your screen, use the general projectile motion formulas to solve. And in this very case, we're going to combine two formulas. And what are the formulas? We're going to combine the formula for the range and the formula for the maximum height, okay, in order to simplify and arrive at this very solution. Now, let's get right into it and see how far we can go with this. All right, I've already written down our given data. And then let's see how far we can go with this. The range formula is equal to u squared sine 2 theta all over g. This is the range formula. And why am I bringing it in? Like I said, it's because of the condition given in the question. It was launched on level ground. It also fell on the same plane. So we're going to use this general projectile motion formula to see how far we can go with it. And then for the maximum height, which is h, the formula for the maximum height is given as u squared sine squared theta all over 2g. These are the two formulas that we're going to use to solve this very problem. First and foremost, I'm going to manipulate the two formulas to solve for u squared, which is the initial velocity, right? In case you're not familiar with this formula, let me define the given parameters right here. The r represents the range, which is the maximum horizontal distance the projectile covers. The u squared represents the initial velocity, because when you throw up something, it's going to be thrown with an initial velocity. So velocity is involved here, but we're not giving the initial velocity. Now the next one here is the angle, which is the launch angle, right? Good. Now down here is g. G represents acceleration due to gravity, and the value is 9.81 meters per second. And for the next formula here, this is height. The height represents the maximum height attained by the projectile from the point of projection, right? If you look closely at this diagram, it's going to reach somewhere here before it starts falling down. And this is the maximum height of the projectile. For part A, it was given as just h. Now, this is also our initial velocity all squared. This is the sine of the launch angle. As you have, this g here is being multiplied by 2. And the g is just acceleration due to gravity. Now, I'm going to solve it this way. We are going to make u squared the subject of the formula in both cases, and then equate them together. Let me show you what I mean. If you cross multiply right here, this is going to be r over 1, right? Because any number divided by 1 is still the same number. So if you divide r by 1, it's still r. Nothing has changed. Now, u squared sine 2 theta multiplied by 1 would give us u squared sine 2 theta is equal to r times g gives you rg. Now, to isolate u squared, we have to simply divide both sides by sine 2 theta, right? So this is now going to be rg over sine 2 theta. Now the sine 2 theta and the sine 2 theta, which is on the left, they cancel out, and you're left with u squared is equal to rg all over sine 2 theta. So we call this our equation 1. Now let's work on the second one. For the second one here, if you cross multiply again, what shall you obtain? We have that this is over 1 as well. Now u squared sine squared theta divided by or multiplied by 1 will give us u squared sine squared theta is equal to h2g, right? So everything here multiplied by 1 gives us this, and the h multiplied by the 2 g gives us h2g, or I can still write it properly this way. We have our u squared sine squared theta is equal to 2hg. Good. Now, to also solve for u squared, we divide both sides by sine squared theta. Let's do that. Divide both sides by sine squared theta. Divide both sides by sine squared theta. This one, they cancel out. We now have that our u squared is equal to 2hg all over sine squared theta. We call this our equation 2. Correct. Now, this is just a mere mathematical manipulation which you need to know how to do. It's really very important. If you look at the first equation here, equation 1 is u squared. Equation 2 is also u squared. Since u squared is equal to everything here, and the same u squared is also equal to everything here, what do? We equate them together. Okay? So, in this case right now, u squared is equal to u squared, right? Now, since they are the same, we can now go ahead and equate the two of them together. And when we equate them, what shall we obtain? We now have that, please, you need to be very conversant with this. Once we do this mathematical manipulation, you can equate them together because they're now equal. So we say RG all over sine 2 theta is equal to 2hg over sine squared theta. Okay, since they are mathematically equal, you can now equate them together. Okay, now next thing, remember that we're looking for the angle, which is the launch angle, right? They asked us to prove something like this, which is this. So we have to find a way to make theta the subject of the formula and check if we're going to arrive at that solution. Okay, now the next thing I'm going to do right now is to cross multiply in this case. Let me cross multiply. When I cross multiply, 2hg multiplied by sine 2 theta would give us sine 2 theta 2hg, okay, is equal to, now sine 2 theta multiplied by rg will give us sine, sorry, this is a sine squared, not a sine 2. This gives us sine squared theta rg. What next? What do we do? Remember, we want to isolate this theta here, okay? We want to isolate the theta, and it's really very important. So to do this, we have to divide both sides by g. Divide both sides by g. Since g is common on both sides, the g on the left cancels out with the one at the bottom. The g on the right cancels out as well with the one at the bottom. And we're left with sine 2 theta, okay, multiplied by 2h is equal to sine squared theta r. Now, what do we do? I want you to understand something at this very point. Do not even make a mistake of trying to divide both sides by sine. Please, this is a sine 2. It's a double angle. This one is a sine square. They're not the same. So don't make the mistake of trying to divide both sides by sine. But we're going to apply trigonometry here. Let me give you one tip. So you need to recall that sine 2 theta is a double angle identity. And we're going to replace it with its equivalence. Sine 2 theta is equal to 2 sine theta cos theta. This is trigonometry, right? Sine 2 theta is a double angle identity or a double angle formula. So whenever you see sine 2 theta, it is mathematically correct to replace it with its equivalent, which is 2 sine theta cos theta. Now let's do the replacement right away. So here we have 2 sine theta. I have done the replacement. Cos theta multiplied by 2h is equal to sine squared theta times r. Good. So at this point right now, let's go ahead and divide both sides by sine to eliminate the sine, okay? We divide the left one by sine. We divide the right part by sine. The sine on the left cancels out, and you're left with 2 cos 2h is equal to, so you have 2 sine, like it's a sine squared on top divided by sine to the power of 1 down. You're going to left with sine theta multiplied by r. Okay, now what's the next thing that we're going to do at this very moment? This is a cos theta. Okay, good. Now, since the 2 is not in between, okay, since the 2 is not in between the cos and the theta, you can multiply these two together, right? Since they are not really in between, or like one of them is not in between the cos, you can multiply them together. But for the first one right here, you can say 2 times 2 because this 2 is in between the sine and the theta. So they're not going to go together, right? This is a double angle identity. Okay, let's continue. So the next thing I'm going to do right now is to divide both sides by cos. Okay, I'm going to divide both sides by cos to see what we shall obtain. If you divide both sides by cos theta, the cos theta on the left cancels out with the one down here, and this now becomes sine theta over cos theta. So let's copy it down. Here we now have 2 multiplied by 2h, okay, is equal to sine theta over cos theta multiplied by r. Let's multiply this out right now. 2 times 2 gives you a 4, and remember that they are multiplied by the h. You also have to bring down the h. This is equal to sine theta over cos theta multiplied by r in this case. At this point, we're also going to bring back our trig identities. We have a quotient identity that says whenever you have, I'm going to write recall, whenever you have sine theta over cos theta, this is equal to a tan theta. Sine over cos gives you a tangent. It is a quotient identity, and you have to memorize it and understand its relationship with sine and cosine. Now, this implies that wherever we see sine theta over cos theta, we are going to replace it with a tan, or we're going to replace them with a tangent. Therefore, we shall now obtain 4h is equal to tan theta multiplied by r. Let me write it properly. Here we have tan theta multiplied by r is equal to 4h. Next up, what are we supposed to do? We're given our range. Remember that our range was given as 10 meters, as we have right here. So we're now going to substitute a 10 for r. Since r is equal to 10, let me write it here properly. I would say recall that our r is equal to 10 meters. So this implies that wherever I see r, I'm going to replace it with a 10. Therefore, we have tan theta multiplied by 10 is equal to 4h, right? Now, to isolate tan theta, what do? We simply divide both sides by 10. Divide both sides by 10. The 10 on top cancels out with this, and we're left with tan theta is equal to 4h all over 10. But 4h over 10, this is a fraction that can be reduced further. If you divide 4 by 2, you have a 2 left. And if you divide 10 by 2, you have a 5 left. So we now have that our tan theta is equal to 2h over 5. Let me continue up here. To solve for theta, what do? We simply take the inverse, right? So we say that theta is equal to tan inverse 2h all over 5. Okay, so to solve for theta in this case, we take the inverse, right? Since it's tan, it's going to be theta is not equal to tan inverse, right? So let's do that properly. We have that our theta is equal to tan negative 1 2h all over 5, hence shown. All right, so we have solved part A, and we have also derived the very expression we were required to derive, and here is a solution right here. Okay, so all you need to know is that you're going to apply double angle formulas and also quotient identities for the simplification of the expression and for you to arrive at your desired solution. This is how it is. Now let's go ahead and solve for the launch angle. That's the next thing that we are supposed to do right now. Now, from the question we're given, they now said for part B, okay, that the height is equal to 7.5 meters. So in this case, if the height is equal to 7.5 meters, find the launch angle. And from this expression right here, we've already found that the launch angle is equal to, our launch angle is equal to, which is our theta is equal to tan negative 1, which is tan inverse 2h all over 5, right? Now, since the height is 7.5 meters in this case, wherever we see h, we replace it with 7.5. Therefore, if we do a replacement, we're going to have that theta is equal to tan inverse 2 multiplied by 7.5 all over 5. We now have that our theta is equal to tan inverse 2 times 7.5 will give us a 15 over 5. If we simplify further, we have that theta is equal to tan inverse 15 divided by 5 gives you a 3, right? Now, if you punch tan inverse of 3 on your calculator, let me do that using my calculator. So theta is equal to tan inverse of 3 is 71.56 degrees. Therefore, our answer now becomes 71.56 degrees. This is our launch angle, and here is a desired solution. I believe you understood all I did. All you need to know is to know how to manipulate all these formulas to achieve your aim with them. Thank you for standing by and for sticking around. See you in the next video, and bye.